Hi everyone, today we are going to discuss about a topic called capacitors. So in entire electrostatics we had a discussion about Coulomb's force between the charges, field calculations, potential energy and a dipole. After this Gauss law, entire use of Gauss law, and the last topic which left in electrostatics is capacitors. Then after this we will go to current electricity. There are two branches now. So in electrostatics the last one is capacitors, right? So now in this entire thing how many topics are subtopics are there? So we will have a discussion of what is a capacitor, what is a capacitor, and what is the formula for that, means how to calculate capacitance, how to calculate, and how many types of capacitors we have, and the second one, combination of capacitors like series connection and parallel connection of the capacitors. As you learned in previous classes that electricity resistors connected in series or parallel, in the same way we can connect capacitors in series or parallel, that is combination of capacitors. Force between two plates of capacitors and energy stored in the capacitor, the finally the discussion of dielectric materials kept between the capacitor plates, dielectric materials, and some numericals based on these all. So these are the topics we have in capacitors. Okay, so everyone may start like this, but now I want to go in a different way, because see, by going the formulas, way of knowing the formulas, by hearting the formulas, you may able to do the problems, but if you understand the basic concept, then it is very easy to go with the capacitors. Okay na? So before this I will go by the method of asking some questions like what is a capacitor, what is the meaning of capacitor, what is the meaning of the capacitor. Generally capacity is nothing but, capacitance is nothing but capacity of a conductor to hold the charge. Capacity of a conductor, to hold the charge, means you know from the previous discussion, when a charge is given to the hollow sphere or a conductor, it stores on the outer surface. That ability or a capacity of what? A conductor to hold the charge is called as a capacitance. What this is called as? Capacitance. Now my question is, sir, can the conductor holds as much charge as we give? No. For example, if I give 20 coulombs, okay, it may hold the charge. If I increase, keep on, can it have a tendency to hold the entire charge whatever I will give? No. There is some limit, because if it is like that, then infinity charge can be held, so that capacitance will be more. So in practically this is not possible. So there is a limit for that. There is a limit for that. That depends on the some things like size and the shape of the conductors, and in which medium it was kept. So based on those things, there is a limit for that capacitance. Now generally, how to discuss those all the types of things? See, here the main thing is that holding the charge. So when you give some charge, holding the charge. Okay. Now in the electrostatics, we had a discussion that let me take a closed conductor. Now I am giving a charge Q to it. When charge is given, it can produce some electric field and it can get some potential on the surface, right? Okay. So we know that if it is a spherical body, so voltage potential formula is 1 by 4 pi epsilon naught Q by R. So when you are giving the charge, then potential is generated. Now here I am taking some different points, like this. See, this is the point A, and this is the point B, this is the point C, like so. This body is irregular shaped. If it is a regular shaped, automatically the charge will be distributed uniformly, but it is not a uniform. So I may say that this at this point, the point radius of cross section like this, radius of curvature, this is the radius of curvature, and this is the point where the sphere will be like this, and this is the point where the sphere will be like this. So here in electrostatics, we may say this point has the surface, so that it has some area, it has some surface charge density. Now you know that surface charge density sigma is charge upon area. This surface charge density is inversely proportional to radius of curvature. Means if lesser the radius, means sharp. If it is a sharp edge, means lesser the radius means small sphere you will get. So if lesser the radius, you will have more charge density. As sigma is inversely proportional to radius of curvature, lesser the radius of curvature means sharp edge. There the more charge will be present. That is what the use of lightning conductors. When lightning strikes the building, see, there is a pin pointer like a wire. Lightning conductors will be passed through the walls of the building. Okay, so there the edge is very sharp, means the entire charge will come and try to store on that point. Because why? That lightning rod the end has less curvature, less radius, sharp edge. So at sharp edges, charge stores more, charge density more charge will be stores. So compared to this, the radius of curvature is different, so that there is a tendency to more accumulation of the charge. So more charge will be created. Here also, if I take like this, so this curvature will be very less, so that more charge will be created. Okay na? So when charge is created, you know that charge can produce electric field. When charge is created, it can produce some electric field like this. You know, if it is a plus charge, electric field lines will start. Now sorry, some voice has missed. So I will explain once again. So when I am increasing the charge, I am adding more charge. So keeping more charge on the conductor, automatically if I add charge, the charge will be increased and charge density at that point will be increases. Charge density at that point will be increases, which creates electric field more. More the charge, more the electric field. So due to this electric field, see, around the body there are some molecules of air molecules are some material medium. So these molecules becomes polarized, polar molecules. So here this molecule contains positive as well as negative. So this molecule becomes non-polar molecules becomes polar molecules, means this electric field applies some force on the positive and some force in this manner on the negative. So the around the conductor the molecules become polar. Now if I keep on increasing the charge, more field will be generated, and at an instant there this molecule get just plus charge and negative charge pulled out like this, because you know that plus charge minus charge, on the plus force will be like this, on the minus force will be like this, because you know electric field will be in this direction. In the direction of electric field, on positive charge force will be there, opposite to the direction of electric field force is on the negative charge. So that when you pull the molecule like this, at some instant they will just come out, there is a failure of the junction, you can say. So all that fracture, you can say fracture. So all the molecules gets positive ends detaches, so that those positive ends will move in the direction of electric field. The negatives may come to this end. So the molecular positives may go in the direction of electric field, negatives will come to the charge distribution. It means that there is a discharge takes place, you can say fracture takes place, that is called as a coronal discharge. So this medium plays a crucial role. At some instant of charge, at some instant of electric field, there is a discharge takes place. So at that instant this positive charge will move, but negative charge will add. It decreases the charge now, because already we are adding charge. Now at this instant negative charge is adding, means is there any further increase of the charge taking place? No. Holding the charge stops at that instant, means the capacity of holding the charge, the capacity to hold the charge at that instant of electric field stops. That is why holding the charge also has the limit. That is why I can say that capacitance has some limit. The holding the charge for a conductor has some limit. That capacity depends on the shape of the conductor. So this depends on, sir, the capacity depends on what? The capacity depends on shape and size of the conductor and the material surrounded by. See, if this material medium is a dielectric constant so there may be more electric field of discharge will be there, so that it can sustain up to some instant, so that more charge will be accumulated. So depends on the shape, size, material surrounded by, the capacity can vary, the capacity can change. That is why the capacitance has some limit. And did you understand? So this is what actually taking place. We discussed what is the capacity. Capacity means holding the charge, and my question is, can it hold infinite charge? No, there is a limit. Why that limit takes place? I have explained by taking a conductor of different radius of curvature So that is how there is a limit for the capacitance, right? So in generally how to define, how to get the formula for, or how to get the calculation for capacitance. See, in generally the charge is directly proportional to the potential. Charge is directly proportional to potential of the surface. If you give more charge, more potential will be generated. That is why there is a directly proportional, so that we can keep a constant. Q is equal to some constant which is nothing but C. So where this C is called as a capacitance. Now Q is equal to CV. Now what is C? C is called as capacitance. So capacitance of the conductor is nothing but Q by V. So where Q is called as a charge given or charge stored, and what is the V? V is the potential of conductor, right? Now, so how to find out? See here, what is the SI unit of charge, SI unit of capacitance? This is Q means coulomb per V means volt. So coulomb per volt, also called as, there is a scientist name Farad. So Farad is the SI unit of the capacitance. But Farad is the bigger unit, that is why we can use the Farad symbol is this much, this one, and we can use millifarad, milli, micro, nano, so farad, so microfarad. So you know microfarad is nothing but 10 power minus 6, nano 10 power minus 9. So as the farad is a bigger unit, we are using this. Okay, right. Now we are just going to discuss how the capacitance can be calculated. Here what we are doing, we are just, what capacitor means, holding the charge, we are giving some charge. So the entire capacitance is about charging. So we are giving a charge. So I will take a conductor, which is initially neutral. Now I am giving a charge Q, so that what is the surface potential at this point P? V. Now what is the capacitance formula we got? C is equal to charge upon the potential. So if you know the method of charging, then it is very easy to find out the capacitance. So we are giving the charge. Sir, from where we are giving the charge? We know that we are giving the charge by taking from some infinity to the point. So we are doing some work done from infinity to the point P. So that is why here infinity point we have taken, from this infinity we are taking to the point P. That is why this will be nothing but charge given by this potential V is nothing but V at point P minus V at infinity, because this is not potential, this is a potential difference. From where we are taking from infinity and we are giving the charge Q. So at the point P on the surface, you know that on the surface potential is same. Conductor is a equipotential surface. So you can take any point, potential is same. That is why Vp minus V infinity. But you know that V infinity in general reference point 0. Voltage at infinity is 0. That is why we can say capacitance is equal to Q by V. This V is called as V at P. Okay. Now, so this is for a single conductor. Now, if I take, see here I am giving the charge from somewhere infinity. Now, if I take another conductor, then how to take? See, I have taken a conductor A and a conductor B. Now, from this conductor I am giving a charge Q. So, I am giving a charge Q to this one. So, automatically this charge will be plus Q. Now, when Q charge is given, leftover is minus, because you know that electrons jump, so some charge is left, so that this will be minus Q. Okay na? So, one charge Q is given to the conductor A. Here method of charging is done from where? B. Who is giving the charge? B. Right. Now here in the previous we took the charge from infinity, but now here we took the charge of some nearby point. So that is why we can say the capacitance of the system, the capacitance of the mutual capacitance, we can say mutual capacitance, because here we have two bodies. Mutual capacitance of the system is equal to charge given is Q, and what is the V? V is nothing but potential difference between the two bodies, because in the earlier we took from infinity to P means Vp minus V infinity. Now you can say that charge by what is the V we are bringing from here. So voltage or potential at A minus potential at B. Generally we can take a magnitude for that. So this is what the real meaning of the capacitance. Capacitance can be find out by the formula charge upon potential. That is not potential difference. So if you know the potential difference, if you know how to find out the potential difference, then it is very easy to find out the capacitance of the system, right? Now I will take an example. See, I am not teaching you this types of capacitors, parallel plate or spherical capacitors, cylindrical capacitors. I am giving a general method to find out the capacitance, then you can easily do the capacitance for whatever they will ask. So I will take two bodies, capital A and capital B, whose radius is small a and this is B. They kept a distance small r. You know that smaller, I have given smaller is more greater than A and B. Sir, why? So if distance is more, there is induction process is eliminated. If distance is less, so that charges distribution is made different. So what I am doing is I am giving the charge Q from this body to this body. So automatically this charge will be plus Q, and when charge is given, this will left with minus Q. Now for this, how to find out the capacitance? So capacitance C is equal to charge given by potential difference. Now what is the charge given is Q, and what is the potential difference? Here bringing from B to this body B to A, so VA minus VB. So firstly we need to find what is VA, what is VB. So VA, so what is VA? Potential on the sphere, potential on sphere A. Okay, now due to these two charges, as we learned from electrostatics, potential on the body A is because of its own charge plus Q, and also because of this one also some potential will be there. So plus potential will be there due to minus Q. Now V at A is nothing but what is the potential due to the own? It is a sphere, hollow sphere. You know that on the surface potential formula is Q by R. So that K, what is the charge? Small q. What is the radius? A. So Kq by A plus, due to this negative charge, here I want the potential. You know that at center and on the surface potential is same. So I am just finding because of this charge what is the potential here. Now you know that general formula Kq by R. So what is the K? Q is minus Q. What is the distance from here to here? R. So simply K into minus Q by R. This is potential on A. So Kq by A minus Kq by R. In the similar way, find out the potential on the B due to the own charge plus due to the this one. Now due to own, you know that minus Kq by B, because due to the own formula is Kq by R. So K into charge is minus Q and the radius is B. So minus Kq by B plus, due to this charge will have some potential here. So this charge how much? Q, and what is the distance? R. So K Q by R. So this is the potential at A, this is potential at B. Now we want potential difference VA minus VB. So if you do the difference, so KQ by A minus becomes plus KQ by B. This is minus KQ bar, this is minus 2KQ by R. But you know that R is more large, so that this term will be 0 because R may be infinite, you can say something. So this will be neglected. So what is the potential difference? So KQ we can take it out. So 1 by A plus 1 by B. The LCM will be AB. So it can be written as 1 by K value 1 by 4 pi epsilon naught. So Q, this LCM is AB and you will get A plus B by AB. So this is how we got the potential. Now come to the calculation of capacitance. C is equal to charge upon potential difference. Charge upon, what is the potential difference we got? 1 by 4 pi epsilon naught Q into A plus B by AB. Q cancels, we may write this one as 4 pi epsilon naught AB by A plus B. So don't go by formula method. So how to find out the capacitance? So C is equal to Q upon V. So you can find out the potential difference first between the two conductors. Then charge upon that one will give you the potential, that capacitance formula, right? So this is how to use the method of calculation of the capacitance, right? Now this you can say by the method of this one you can derive parallel plate capacitance or cylindrical plate capacitance or some anything, okay, that we will do later. Now my question is how to increase the capacitance. See, we got the capacitance formula and here we discussed what is capacity and what is the capacitance formula. Now my question is how to increase the capacitance. Is there any method of increasing the capacitance? So we already discussed capacitance depends on the size, shape and the material in which it is placed. And for example, see, I have a conductor A and I have given some charge Q, so that this surface got the potential V. Now what is the capacitance? Simply capacitance formula, charge is Q upon voltage is V. On the surface I will write S. So this is capacitance. C is equal to Q upon V. We are bringing from infinities, okay, right. Now is this capacitance value changes? Is this capacitance value changes if I keep any conductor, another conductor surrounded by? Means if I bring any another conductor, will it affect the capacitance? We will see. Definitely it will affect. See how? I am taking a neutral conductor. I am taking a neutral. See, when I bring very close, you know that this is plus, charge is given already initially. When I bring close, due to the induction on this conductor, due to the induction negative charge will induced here and here plus charge will induce. You know that due to the positive, opposite charge induced in the near surface, same charge further. Now here this negative charge will have some potential here and this positive charge also have some potential here. Now the capacitance of the system may change. Now what is the capacitance? C dash I will write. So what is the formula? Charge by what is the voltage or potential difference? Already initially V surface is there. V surface. Now on this surface, due to this negative, we have some potential, that is a negative potential. So that you can say minus potential due to negative charge, and due to this positive some potential will be there. Means now potential is changing because bringing the another body, what it changes? Potential changes. Potential of the conductor changes. So due to this plus So this is due to minus, and due to this plus some positive potential will be there. Now what happens to this value? See, this is Vs, okay. Now this is negative potential, this is positive potential, but you can say for this negative potential the distance is less. For negative charge R is less, means distance is less, means it will have more potential. For the positive charge, the distance from the surface center is more, so this potential will be less, hence more domination is negative. Hence we can say that this C dash has the Q by V surface, and this is minus of something is more, because this, if these are equal, cancels, we will get a Vs. But what I am saying, due to this negative, as negative is very closer, the potential due to this on this conductor is more, hence this V becomes, this voltage is decreasing. When voltage is decreasing, what becomes capacitance? Inversely proportional, means initial capacitance is C, now C dash. What is the relation between C and C dash? Can I say, as the voltage is Vs here, now the voltage is less, as Vs minus V plus is less than V surface, this denominators. As the denominator is decreasing, the numerators can be increased. So you can say that C dash is more than C. So by bringing a neutral conductor near to the original one, the capacitance is increasing. The capacitance can be increasing, right? Now, sir, so here by bringing the neutral conductor, if I earth the conductor, then what happens? See, initially this is plus Q, and here due to the distribution this is negative, this is plus, and I am earthing this one. I am earthing. When earthing is there, this charge will taken by the earth. So only what is left? Negative, means the potential will be V surface already there because of own charge, and due to this negative, some minus V due to negative will be there. So now still the potential is becoming less, because here initially is Vs only, but now some negative voltage is created, so that potential is still decreases. When potential decreases, we know that the capacitance C double dash I will take Q by voltage V surface minus V due to negative charge. So as it is decrease further, it can increase further. Now what happens to capacitance? Keep on, we are decreasing the voltage, we are decreasing the potential, so that capacitance increases. So this is the method of increasing the capacitance by placing a neutral conductor nearby and by making the earthing connection to the neutral conductor. This is how to increase the capacitance of the capacitor. Okay. Now we will see different types of capacitors. We will see different types of capacitors. What happens? So spherical capacitor. Sir, what is spherical capacitor? Take two hollow spheres of radius R1 and radius R2. From this sphere I am giving a charge Q, so that this becomes plus and this becomes minus. See, capacitance, for the capacitance we are giving the charge. Who is giving the charge? This one. To whom? This one. That is why plus Q here, this is minus Q. Okay now, so how to find out the capacitance of this one? You have the formula, C is equal to charge given is Q and voltage difference, potential difference. So potential difference for what? This is the sphere A and this is the sphere, hollow sphere B. So I can say that C is equal to Q upon VA minus VB. We know that VA is high potential. So how to find out the capacitance? If you find out the voltage or potential difference, then it is easy to find out the capacitance value. Sir, how? So firstly find out potential at A. See, potential at A, because of its own, what is the potential? K, charge is Q by the radius is R1, because of its own. And because of its negative, this negative charge, what is the potential? See, we are finding because of this, where the point is here, means this is inside na, we have discussed potential inside, potential on the surface, potential outside. Now potential inside, which will be equal to the surface only. So because of this one, because of the minus Q, the potential will be K into minus Q by, when potential is inside, you can take this radius. So B, this is R2. So potential at A is nothing but KQ into 1 by R1 minus 1 by R2. This is potential at A. In the same way, you find out potential at B. Potential at B, potential due to the own sphere and potential due to this sphere, we need to find at this point. Now firstly due to own sphere, K into charge is minus Q, the radius is R2, and due to this we are finding here, means due to this means point is outside na, for this sphere point is outside. You know the formula for outside, KQ by small r. So plus K into, what is Q, what is the charge of this one? Q is Q by smaller is this radius R2. So this is potential at B. So automatically you got potential at A, potential at B. So you do potential difference, VA minus VB. So taking KQ common from all of them, so it is 1 by R1 minus 1 by R2, minus of this one becomes plus 1 by R2 minus 1 by R2. So anyhow these two cancels, we left with only these two. So potential difference is equal to K. What is K? 1 by 4 pi epsilon naught into charge. This is 1 by R1 minus 1 by R2. LCM will be R1 R2, and here you will get R2 minus R1. So this is delta V. Now you want to find out charge. So capacitance. So what is the capacitance formula? Q upon VA minus VB. VA minus VB, you can write this one. So what is that one? 1 by 4 pi epsilon naught into charge into R2 minus R1 by R1 R2. So Q cancels. Now we will get the capacitance of the spherical capacitors system as 4 pi epsilon naught R1 R2 by R2 minus R1. So if you know that the way to find out the capacitance, it is easy to find out the capacitance for any type of the capacitors, right? Now if you see a parallel plate, well, there is one more type of capacitor which is very important one. Parallel plate capacitor. Parallel plate capacitor. So what is parallel plate? You know, non-conducting plates are there. Sorry, conducting plates. So there are taken two plates. First, this is one plate and this is another plate whose distance of separation is D given and area of the surface is A. Okay na? Now we know the method of charging capacitor means you can take some charge Q from this plate, so that this will be plus Q, this plate will be plus Q, and when charge is given this plate will be minus Q. And in previous conducting we might have discussed, when charges are Q1, Q2, all the surfaces have the charges which are in the outside, average of the charges Q1 plus q2 by 2 here, and inside we can find out. In the same way, if it is plus q, this is minus q, the outside charge will be 0. The outside charges will be 0. Okay na? So this forms a parallel plate capacitor. In the parallel plate capacitors, we have taken two plates, two conducting plates, and distance of separation is d, and area of the plates are a. One plate is given a charge q, so that first plate is q, second plate is minus q. Now how to find out the capacitance? How to find out the capacitance of the parallel plate capacitor? What is the method we have? C is equal to charge given by potential difference between the plates, right? C is equal to q by v. Now what is the potential difference? Before going to this, we know already, if I take a point P here, what is the electric field? What is the electric field due to this plate? This plate will push the P, so that electric field will be this direction. This is due to the first plate, and due to the negative plate will attract the test charge, so that negative plate field also in the same direction. So what is the net electric field at point P? You know that due to the first one, E1 plus E2, which is nothing but E1 is sigma by 2 epsilon naught, you know already, sigma by 2 epsilon naught, E2 also sigma by 2 epsilon naught, then becomes sigma by epsilon naught. This is electric field. When electric field is there, you know the method of finding potential difference. You know the formula of potential difference, delta V is equal to electric field into the distance in electrostatics. So V is equal to ED. Okay na? So, or you can get the by method of minus of integration of E bar dot dr bar also, right? So delta V is equal to ED. So delta V is nothing but from positive to negative, E is sigma by epsilon naught into distance d. Now this sigma is what? Sigma is nothing but charge per unit area. Charge is q, unit area A, epsilon naught d. Now how to find out the C? We got the potential difference. Then C is equal to charge by, what is the potential difference we got? Q d by epsilon naught A. Q cancels. We can say that epsilon naught A goes up, epsilon naught A by d. So this is the formula for parallel plate capacitance. Parallel plate capacitance. What is the formula? C is equal to epsilon naught. We know epsilon naught is nothing but 8.85 into 10 power minus 12 coulomb square per Newton meter square, and A is the area of the plates, D is the distance of separation. They might ask you problems like this. If distance is doubled, then what happens to capacitance? So distance and capacitance are inversely proportional. Distance and capacitance are inversely proportional. C is inversely proportional to distance. If distance increases, capacitance decreases. And C and area directly proportional. If area is increased, capacitance of plates will be increases. Right. Now, sir, here air is taken. Free space air is taken. If you keep any material, dielectric material of dielectric constant K, which is epsilon or relative permittivity from electrostatics, relative permittivity is equal to epsilon medium by epsilon naught. So that is why epsilon medium is equal to epsilon r into epsilon naught. Epsilon r also called as a K, which is called as a dielectric constant. So K times epsilon naught. Okay. Now if I keep inserting some material in this one, so between the plates, if I insert some material rather than the vacuum or free space air, some material of ER is kept, then what happens to capacitance? You know that capacitance is epsilon naught A by D. In the place of epsilon naught, you can keep medium, which is C dash becomes, in the place of epsilon naught, I can keep epsilon r into epsilon naught A by D. And you know that this is already old capacitance when empty space air is there. Now in the dielectric, C dash becomes epsilon r times original C, where epsilon r also called as a dielectric constant of the material medium. So where dielectric constant is defined as what? It is the ratio of the permittivity of the medium